I want to thank our sponsors very much for sponsoring us, Verisprite, the people at Fitbit, and HackerOne. And without further ado, here's Arian and Steve.
Yeah. Sweet. Thank you, everybody, for coming today. We have a very dry presentation. I think you're all going to like it. I'm afraid to touch this. If it seems like we're really extra gentle, we found that a one press disconnects this. So, who are we? Steve, introduce yourself.
Hi, I'm Steve Ginty. I'm the product manager for Passive Total, one of the co-founders of the Passive Total platform, security researcher. And this is great because I'm a beer aficionado and I get to do security and drink a lot of beer all at the same time.
My name's Arian. I got started in this mess building financial applications. So I got to meet the Russians and the Chinese and the Secret Service, and that got me into forensics, which has led me to here today. And most of what I found in this presentation, I just find by accident. Steve's a smart guy here. So this presentation is about, it's really two sides of what's essentially the same coin. We've been studying how bad guys, we've been studying how bad guys target and attack people. What are their tools, techniques, and procedures, and what data sets do bad people use when they go after people? And we've been looking at ways that we can leverage the same TTP and data sets to help defend ourselves. So we're going to talk about that, and we're going to talk about turning that back around at the end on the bad guys. So the goals of this talk are really, we want you to walk away with an idea how both red and blue teams can leverage some new data sets we've been working with in your existing TTP to give you better visibility of who's attacking you, what they're setting up, where they're going to attack you next, trying to turn the table back around on the bad guys. We learned some interesting lessons doing this. So starting about 2 years ago, I wasted a year talking about the data sets specifically. And after about a year of presenting on data sets, the same people who had the same problems that I talked to weren't using the data sets that could help them. They weren't doing anything new and they were having the same problems, which led me to realize that just talking about data sets is not only boring, but people can't act on it. So today we're actually going to talk about some newer data sets combined with traditional data sets most of you are probably already using in one form or another, but we're going to specifically show you how to combine them and show you some free tooling you can use in investigations, because what we've found is if essentially we don't hand it to people prepackaged in a way they can use it easily or fit it into their existing TTP, that people just don't have time to sit down and research and play around with a lot of these new data sets. So that's the goal, show you how to do it and give you an easy way to do it. You should be able to walk out of here and do everything we just did today when we're done.
So we're going to dive in here. Arian just showed a couple of the data sets that we at RiskIQ use to track adversaries, and we want to kind of impart the best way to go about using that information. So the whole point of this talk is to discuss how we can use web crawling and infrastructure chaining to allow us to better hunt our adversaries, those people that are targeting us. And so how do we do this? Traditionally, we've been doing this for a while. We're using interconnected data sets to find relationships between things. Domains connect to IPs. There's malware that associates to domains. You have CNC, command and control, domains or IP addresses. All of these things kind of interconnect with each other. And if we present that data in an easy way to interact with, you can start to surface new connections about your adversary. You can possibly substantiate your thoughts about why the adversary is targeting you or how they're targeting you. And you can hopefully start to group activity in a way that makes it easier to defend your network. So what do we know about traditional data sets? You're going to see these little polygon octagons all over the place. But what we have is traditional data sets in Passive DNS and Whois. Organizations have been using this for a while. What we are saying is, let me look at this command and control domain or IP address. Let me look at this domain that was used to download malware to my network, and let me expand from that piece of data to understand the adversary at large. And so these are tried and true methods. We start with an IP address. We find additional domains that associate to that IP address over time. From there, those domains associate to other IP addresses, and we're slowly chaining out information to bring context to our investigation. Additionally, Whois data allows us to take facets of a Whois record and quickly understand, if this email address was used to register a domain, maybe it was used to register other domains. Maybe this phone number or address or specific piece of information in that record was used to register additional domains. We're basically building off of poor operational security and human error. When people start to register domains, they're going to possibly do the same thing over and over again because humans are creatures of habit. And so we can use that scenario to identify additional parts of the actor infrastructure and again, use that to defend our network. So like I said, this is traditional data. We know this. We have to expand beyond this.
How many people here are incident response or blue team that actively are doing investigations today? How many folks here are wanting to learn how to do that, more of it? How many folks here are like red team, pen tester, reverse engineer? Okay, so we've got an interesting mix and a lot that...
So building off that kind of traditional methodology of chaining infrastructure, what do we want to do? We want to bring that tried and true method to other data sets. The reason we want to do this is we found that actors and attackers are evolving. They know as defenders how we're tracking them these days, and so they're using that knowledge to better protect themselves from our investigations. They're responding to our methodologies and privacy protecting Whois data. They're using fully segmented infrastructure so that there's no overlap in passive DNS data. They're increasing their operational security in ways where, 5 years ago, they wouldn't care about it as much. Now people are doing things to stop us from identifying them. And new data sets and tactics are needed in order to really expand our visibility. And on the right, you start to see, we're bringing in other data sets. We're bringing in SSL certificates, facets of those certificates, trackers, host pairs, all these things that I'm going to talk about in the coming slides. And all of these data sets are based off of web crawling. So, crawling to increase context. Now, the idea here is that technology today now allows us to crawl the internet at scale and database that information to gain understanding of our adversaries and also of those that are targeted by those adversaries. So we have the ability to do this, database that information, and not only understand what actors are doing today, but go back once we understand new tactics, techniques, and procedures, and look at our data to say how does this new bit of information layer over the data we currently have. It allows us more insight. And what we're really trying to do again is to use actors' mistakes, exploit poor OPSEC, and look at new infrastructure connections to really understand our adversary. So this is going to be really rapid fire, but the question here is, Arian had mentioned earlier in the talk that he talked about data sets a lot, and people don't always understand the data sets we were talking about. And so I wanted to walk through what's in a modern web page very quickly and what we get from a crawl so you kind of understand how we view this data. There's a lot of different things in a modern web page. Using our crawler, we can understand messages. This may be developer comments. This may be error messages. These things come out as we crawl a web page. We're going to understand links. Most pages are made up of other resources that they're pulling from, and so those links are part of the makeup of that web page. This allows us to know where content is being pulled from. We're going to understand dependent requests. What other parts of the web are websites pulling from to make the page you're viewing today? It's not like websites aren't static anymore, so they're actively pulling things on demand to make that page. Those types of calls can give us insight into is something malicious taking place here. Cookies. Both for kind of legitimate and nefarious purposes, organizations drop cookies as you view a web page. It's normally to track and understand who's visiting their page. Actors do the same things these days. They're dropping cookies to understand who's already visited the page, to profile their user base, to say, okay, have I fingerprinted this person yet? Have they seen this URL? Is this a unique visitor? And we can use this understanding of cookies that are being dropped to do the same thing we do with Whois data. Say, show me everywhere else we've seen this cookie. What sites are they associated with? So it makes it, it's another connection point. Additionally, you see the name scenario. We've seen a lot of scenarios where the cookie name is unique or been fat-fingered. And so when an actor is coding, they'll enter in a cookie name that isn't common. Instead of PHP, SE, SSID, it's PNP. And so we can use that in order to identify unique attributes of an attack campaign. Headers, this is just the sequence of what's going on, how do I build a page, what do I need to know to make that page appear? And then finally, the response and document object model. As we crawl a page, we pull back that page's content. This can be indexed for unique attributes of the page. There's a lot going on with building a web page, including everything defaults to SSL these days. So we now have certificates associated with pages and IP addresses. So it's a lot of different information built from a web page. How do we operationalize this data in order to use these same methodologies of infrastructure chaining? I wanted to walk through that because there's a bunch of different ways we can do this. We don't operationalize all these data sets, but very quickly you can see we can increase our visibility because we can take that link, sequence, and dependent request data and do something very similar we do with Whois data. We can take each of those and create what we call a host pair. That host pair now tells us site X redirected to site Y. What was the cause of that redirect? Maybe it was a top-level redirect. And we can also see that we've seen multiple domains associated with that redirection chain. So site X redirects to site Y, but it also redirects to site Z as well. So now we have an expanded understanding of that attack campaign. And we can use our traditional methods, like passive DNS data, to find IP addresses that associate with that. Additionally, we can use the response and the document object model to understand what we call trackers. These are things like Google Analytics codes, clicky IDs, New Relic, Facebook, Twitter, you name it. Everybody has some type of kind of unique ID that they're pushing to a web page. And we can use that to understand multiple domains that are using that same ID. Usually those are legitimate, but what we found is actors are also inserting JavaScript that looks like an analytics code that we can use to track compromised websites. SSL certificates. We can take a certificate that lives on an IP address, and we can quickly say, what's the SHA-1 of that? Is that SHA-1 been seen on any other IP addresses? Is there a unique facet inside that certificate that allows us to understand additional context or find additional certificates? And we just keep building out our understanding of an adversary network. So that was a lot of we can do this. Let's prove that it actually works. We're going to start with the MageCart example. This is a 2016 cybercrime campaign. It was a keylogging malware that was targeting e-commerce sites. It was injecting JavaScript code into those sites, and it was basically understanding how it was stealing the payment card information as the user was typing it into to checkout of the website. You can see that this is a crawl sequence from our crawler that shows we have Faber, which is a book company in the UK, is redirecting to mageonline.net and jquery-cn.top. It shouldn't be doing that. Both of those are actor-owned domains, and that is how they were redirecting to capture the payment card information being entered. So what do we know with traditional insight to data? We start with the Faber URL. We see mageonline.net. It has some Whois information and some IP addresses associated with it. Those IP addresses associate with thousands of domains, so it's really hard for an analyst to dig in and understand if those are malicious or not. But we have some Whois information that gives us some additional domains, angler.club, and let me look at the screen, magento-cdn.top. Additionally, we have some other overlaps in hosting providers, but that's it. Our kind of investigation stops right there. Whois provided some other domains we could block against, but we don't have a full insight into the attack campaign. If we enhance our visibility with crawl data, what we find is not only was Faber redirecting to magecart.net, but also 45 other compromised sites were redirecting to that actor-owned domain. Additionally, as we start to pivot off of our other known domains, like that Angler Club, we see four other websites that were also infected and redirecting to the actor-owned domain. And within a handful of pivots, we've understood that this isn't just a single incident. This is a significant amount of infrastructure that's compromised and redirecting to those four actor domains that we knew of. So we really enhanced our visibility in what was going on with this attack campaign by using that crawl data. The second example I want to walk through is the DNC attack, Grizzly Steppy. Everybody's been talking about this. There's been a lot of good publications from CrowdStrike, from Threat Connect. But I think the interesting example here is, we have an attack targeting the DNC. It's been attributed to Russia, Fancy Bear, whatever name you want to call the group at this point. We have a couple, if we look at the original CrowdStrike report, we have a couple of CNC IP addresses. We have a couple external implants for command and control. And there wasn't too much you could find out if you looked at that infrastructure to begin with. We find the IPs that they listed. They associate with a handful of domains. Only this one was interesting. And that's it. We have no really other context. If we start to look at crawl data and use our certificate repository to expand our knowledge of this, what we find is there are SSL certificates associated with these IP addresses. Most of them are only associated with a single IP address. But if we look to the far right, we see that large chunk of additional IPs. That's a huge group of possible additional external IP addresses that you identify based off shared certificate. So in a handful of pivots using these new data sets and our tried and true methodologies of infrastructure chaining, we're able to really dig in and understand a much larger aspect of the attack campaigns. Now, since Arian's a very daring individual, he's going to do a live demo of how we would walk through some of this.
I don't even have any booze yet. This is not cool.
We'll get him a beer.
All right. So, we're going to start with a simple example. And basically, I'm going to walk you through this step by step. Like if you were going to do this yourself, these are exactly the steps and the connections you make. And along the way, I'm going to show you some mistakes I made. Was anybody at DerbyCon last year? Okay, so I gave an example I'm going to use here in DerbyCon, and I totally missed a huge indicator that explained a whole bunch of things I didn't understand. I'm going to show you today. But this one, this is a basic fish, and I didn't screenshot it. It's gone now. This is just passive DNS data we're looking at, and so it's no longer live. But this was a Google login form, and this guy, if you actually look at the links and the DOM, he just sources in Google's legitimate assets and puts up login forms. And so we got this Google login form. What does that mean to me? Do I just block it and move on? I got an alert, my user went there and, some endpoint or IDS thinks something bad might have happened. I don't know, where it matched up with the blacklist. Those things can be pretty noisy, blacklist and threat intel. So I want to ask some questions about how dangerous is this thing? Do I really need to care? Do I block it and move on? Is somebody targeting me? Do I need to spin up a whole team and really investigate this and, do I need to put monitors on this? So we're going to look through this data really quick. First thing is this Google? Is this legitimate? Well, I'm going to come in here and I'm going to look at the Whois data. And this guy conveniently leaves his Whois data or some Whois data in here we can pivot off of. So looking at the Whois records, I'm just going to jump over here into the email. And this gives us a pretty clear picture. Let me make this bigger. Can you read that? So basically when you jump into this guy's email, he's got like 25, 35 domains registered, and they all follow this pattern of Facebook and Google fake profile, fake login pages for the various products. This guy seems to have a niche, and his niche is fake Google and Facebook profiles, and that's all he does. So I'm not really worried. It doesn't look very targeted. It doesn't look very legitimate. I'm just going to drop those into something that I can block my users from going to it and move on. If you look through the rest of us Whois, it's not that interesting. When we look at the link data, which is what this host pairing is, we can see they're sourcing in Google assets. Now where this gets interesting though, when I started saying like, well, could this be Google, I jumped over. And if you look at the actual infrastructure underneath it, it's pretty amusing because all his Google and Facebook stuff runs on ASP.NET and an older version of IIS 7, which I'm fairly confident Google and Facebook aren't actively using today. So there we basically walked through and said, hey, he's a phisher. I don't really think he's targeting me. Is it legitimate? Nah, it's definitely not legitimate. I mean, he's copying Unix vendors on .NET stuff. So I'm going to block it and move on. So that's our first example. I promise you the rest are a little more interesting here. All right, this one, this example is a pretty interesting one too. Unfortunately, something just changed on it in the last week or so. So there's a point where I usually get a good laugh that I've lost. I'll tell you about it when we get to where it should have been funny. But essentially, this is one. These folks were active for a while, dropping links on social media. And a lot of social media threats are blended threats. So they'll link back to traditional phishing attacks, or they'll try to link you to a fake mobile app to download, or they'll have a human try to social engineer you. So you'll see these pop up. They're usually sub-24-hour attacks, like fake customer service. You know, you use the hashtag Matic capital 1, and then they'll drop a link in. Oh, here's our customer service guarantee. Come talk to us. At the end of the day, these folks we're going to look at here are just phishers, but let's see what we can learn about them. So we're going to come down here. I'm going to look at the Whois, and unfortunately, this one's a little difficult to extract much because they've anonymized the Whois. And this actor actually just started anonymizing the Whois at the start of the year. Prior to this actor actively advertised a set of Whois that we could use to kind of verify that it was a bad attack. So let's go a little farther through here. I went back and now I pulled historical Whois. It's important when you're doing investigations to have historical data, especially as adversaries are getting smarter about hiding themselves and covering their tracks. So you want a good source of historical data. And the actor I have here, his persona is Hildegard Gruner. And so we can pivot off that. And if we look at Hildegard, he owns a lot of stuff. And actually, if we go through all the different facets, if we pivot off all the facets of his Whois data, we'll find roughly 10,000 domains, somewhere between 5,000 and 10,000. This guy owns a lot of domains, or has historically. So when you first look at this, though, this McAfee and Bitcoin stuff is all brand new. He's into something new. But you look at it, he's got a lot of junk domains and weird typo squatting stuff. It looks like he's been into everything. If you start sorting the data historically, though, you can see as an adversary, it looks like he matured over time. Looks like he got into some basic typo squatting and very basic stuff, and then as the years go on, you can see his attacks start to advance and target specific name businesses, and then they start to get into more campaigns. So I already know who Hildegard is. You know, I know this isn't legit, but are there other points of data sets I can use to verify that my employees or my customers aren't going to what is a legitimate site? I don't want to block this thing if it's legitimate. So I thought, well, let's actually look at the technology stack running on this alleged Capital One bill pay site. So we look at the technology stack. It's running WordPress. It's running IIS 7.5. There's actually not running a lot of stuff here. It's only got 126 components, unique technology components. So I thought, let's compare this to a real. So this is CapitalOne.com, and if we look at this guy here, I'll just pull it up to give you an idea of the numbers. So the legitimate default CapitalOne.com site has over 3,600 different web components on it, where the fake one only had about between 100 and 300. So they're not doing a very good job of impersonating them, as well as the legitimate Capital One links to everyone on the planet. But what was more amusing about this when I dug in is when you come back here to the adversary site and when you look through their components, they actually keep all their components patched and up to date. So if you look through the WordPress, if you look through the jQuery, even the PHP versions, the phishing site is relatively up to date. It's usually within a week or two of new patches and releases. When you go through the Capital One components, what's interesting is actually the legitimate Capital One site does not. When you start looking through their stuff, you'll find old versions. There's ASP.NET 2.0 still running in production here. There's Heartbleed running in production on their Alexa, which is their Amazon Alexa integration for Capital One. If you're using that, it's vulnerable to be sniffed all day long. So they used to have some more components, but I talked about this online once, and then I noticed that the next week the components I talked about got patched. So maybe if this shows up in video online, they'll fix their OpenSSL and other issues too. So again, quick way we can tell the adversary. We've got historical Whois, and we just look at the fingerprints of the technology stack, and it tells us a lot about what's going on. Adversaries more worried about their infrastructure being compromised. So we got that one. We're gonna move on, and this is PNC. I've got PNC Bank being targeted for phish in a similar way, and this is the example that I used in DerbyCon, and I totally missed a couple really important things in here. So we come in here, and we've got a similar kind of problem. If this actor has, instead of anonymizing, they're just using generic bogus information for their Whois today. But if we go back and look historically, I'm saying, like, the question I'm asking again is, hey, is this a real attack? Is it targeting me? How targeted? How worried do I need to be? Do I just block it and move on and don't have to sweat it? We're going to come and look here again, and if we look at the historical Whois, we see this actor Ethan Rhodes. So let's go look and see what Ethan Rhodes has and what that can tell us. We're just going to query some Whois data. Ethan Rhodes doesn't own a lot of stuff, a little over 100 domains, and it looks pretty random. I've got some Samsung keys, driver download site. I've got a traffic quote, a Mr. Rooter. It doesn't look very targeted, doesn't look very threatening. You know, I'm not getting anything here that makes my spidey senses tingle. But let's dig around a little more and see what else we find. So the Whois wasn't that interesting, but he's actually using Google Analytics, which uses urchin cookies as trackers. Let me make this a little bigger so folks can see. And he's got a Google Analytics ID and a tracker here. And let's see what happens if we dig into those. And if we dig into those, we actually get a whole new story. So if we dig into his Google Analytics account and look at his urchin tracking cookies, all we find are PNC banking domains, and a whole bunch of them. So this is definitely a targeted actor that's coming after PNC Bank customer or employees running very focused attacks. Let's see if we can learn a little bit more, though. I'm going to dig in here, and I'm going to look. So what I did here, I guess I should tell you as I do this. So you've got two different things here. You've got the one with all the dash integers is the actual urchin cookie, and then that's the account ID. So I want to drop in to the actual cookie here. So this is a campaign. The 51 is a campaign. So now I've got two sites in here. I've got a new site that I haven't seen before. It's never showed up in my alerts. Let's go take a look. But before I do that, I got kind of curious. I started brute forcing all his campaigns. And when I got to campaign 20, so I went back from 51. This guy, as of the end of last year, had run 51 campaigns against PNC banks. So in campaign 20, I find a new domain that led me to some new info. So as we keep digging down this rabbit hole, wow, look what we found. Interestingly enough, that domain here, bizarrely enough, is owned by Hildegard Gruner, the guy we found in the Capital One banking attack that looked like a random attacker. What is he doing in the middle of this guy's Google Analytics campaign? Well, if we jump in a little deeper here, if we go back, one of these domains has two, and this is very rare, you won't see this very often, two accounts, two sets of tracking cookies. So basically both actors, Ethan Rhodes and Hildegard Gruner, I'm going to have to skip the rest of this because we're almost out of time, but they occasionally run joint campaigns. And the Ethan Rhodes persona tends to run the very focused ones on banking, and Hildegard runs the broader campaigns. But we can start unraveling the nest of everything they're doing and how they're targeting us by tracking all these accounts on Facebook. So for the final one I'll give you, this was another one I found recently. This is a fake Amazon login page, but he sets it up. This actor creates domains that look and seem like Amazon, and they put them all over the web. They host them in Amazon infrastructure. You know, what can I learn about this really quickly digging in? Well, I can't really learn much because this actor actually uses legitimate information for Whois registration for other people. In some cases, what we think is these are actually compromised sites. So they're legitimate sites that are compromised that they put their stuff on and are piggybacking. So when you go to the Whois, this is all going to lead you to legitimate businesses. You're going to go, oh, okay, well, this doesn't look like a bad actor. This is all legitimately owned stuff. If we dig in and we look at the Whois, we're going to find all this Alpine audio-related businesses. So I'm going to blow through all this. What was this one? Oh, phone number. All right, final one I'm going to show you because their time's up. Facebook ID was left embedded in the page. Now that's interesting. What happens when we query the web for that Facebook ID? We find all this Amazon phishing and account stuff that's already been flagged as malicious. So it's an Amazon phisher and a malware distributor, and we don't have time to go deeper, but we captured their Facebook page, and they were actually running a Facebook account advertising their services on Facebook. Now, Facebook's now nuked their ID, but these folks are running a profile and running ads on Facebook, advertising the infrastructure for other people to rent or purchase and use. So that's how you can combine these new data sets to quickly go from confusion or misunderstanding or thinking something's benign to connect all the dots. Thank you very much.
Thanks very much, Arian. Thanks very much, Steve. Here, we got a little gift for you guys from our friends at Fitbit for thanking you guys, and thank you very much from BSidesSF. Really appreciate it.